Hey guys, today I'll be doing a repeating pattern and my name is Kawa Kondo. So my pattern is this one. I have to draw this pattern to look exactly as it is now. So I have to draw it using turtle, turtle module and helper functions, lots of them. Okay, so the first step in creating this type of pattern is to import the turtle and math module. I'm importing the turtle to get the whole screen and the window and the background to work, and then I'm importing math for any calculations that I might need using the math module. And so I import the turtle and the math modules, and then I use the turtle module to select the background color, the speed of the turtle, and to name the turtle. So as you can see, I imported turtle and I imported math, and then I said WN, which is technically I assigned this variable to the screen, turtle.screen, and then wn.bg color. This gives us the background color, and I'm using light blue. And then I named my turtle test, and so like um in order to get the function working, give the we need to give the turtle a name. I gave it the name test. And then this is the pen size, like how thick I want the size of the turtle to be. And I want the color to be black, although black is the default, so I technically didn't have to set it, but I just wanted it to be clear. And then I gave my turtle a title. I said, Test draws a pattern. Like you could use any name you wanted to, and you don't even have to give it a title. It would still work. But I wanted to give it a title. And I used turtle.tracer00. This gives us the speed. It makes it fast. But if we wanted to make it slow down so that we could see every step, we would use test.speed and then 0 or 1 or 2, depending on how fast you want it to be. The second step is like you technically don't have to draw it, but I wanted to draw a big square to act as my border so that I would know that I would be able to like keep everything that I do inside a certain boundary. I didn't want it to exceed a certain boundary. So I said I defined the function big square, and then these are the parameters that I used. And then I used the triple quote docstring. I said it uses the turtle to draw a big square or border around the basic function. So in order to do this, I put the pen up, and then I move back size times 2, size divided by 2, and then I move the turtle left 90 degrees. I move back size over 2. I move right 90 degrees. So like the right and the left, these give us the angles, and the back and the forward, this gives us like forward and backward. And then I put the pen down. So like you put the pen up when you don't want the marks to be drawn, but I put it down because I wanted to draw the big square. So I use this to center the square. So for iron range 4, because it's a square, it has a range of 4. And then we want it to move forward by size left 90. And we put the pen up again because we wanted it to go back to the center after it was done drawing. And I put this out of the loop because if you put this in the loop, it would just mess up the whole function. The third step I did was I created a square function because I have to get little grids so that the function can actually look like a function. And so I so I the fourth step we're defining line of squares, and this is another function. And so I'm using this to get Alex to draw a line of squares. And the reason that I want a line of squares is because I'm still working on getting the grids to show up on the turtle screen. And so like I used the tiny square, which is just one square, to like to use I used it to draw a line of squares. And so I said for I in range 1, comma n plus 1, and then we're saying n plus 1 because Whenever Turtle does the range, it always does one less than the number you want. And so you put the plus one so that it gives you the number, the exact number you want. And then because I am saying I divided by 4, so whenever I, which is this, whenever it's divided by 4 and we get a 1, we want the square to draw using color 1. And then otherwise, if you draw it and you get a 2, we want it to draw using color 1. But if you draw it and you get a 3, we want it to draw using color 2. And else, we want it to draw using color 2. And so the next step, because we're still working on getting the grid, the next step is we're defining a square of squares. And this is where the little square, which we use in the line of squares, and the line of squares, which we're going to use in this is where they come in handy. So like we're still trying to get the grid. So we now have a line of squares. So now we're using those line of squares to create a square of squares. And so first of all, because the size is the border size. So we're saying the size is the border size divided by n, which is the number of grids we want. And so we're saying for I in range 1 and n plus 1, we're saying when I plus modulus operator 4 is equal to 1, the line of squares, we wanted to draw a line of squares. Although when it's equal to 2, we wanted to draw a line of squares. But the colors aren't being touched yet. And when it's a 3, we wanted to draw a line of squares. Else, draw a line of squares. And so after we've done all that, we use this to move we use these out of the loop. Well, not actually out of the loop. We use this to position the function. But after drawing the line, it goes back to where we want it to draw the next line. And then we use this to take it back to the left-hand corner of the turtle screen. And this one gives us alternating squares. So it uses turtle T. So we're using this one, and then the parameters include test. This is the turtle's name, and then size. That's like what's the size that we want each tiny bit of the square. And then this is the first color, the second color, and how many squares we want per line. And so we're saying it uses turtle T to draw alternating squares repeatedly. And so because we have now repositioned the turtle, we want it to get to a certain point so that when we do it, it will I'm sorry, but when we do it, it will continue using the loop without changing anything, and so we can get the image that we want. And so we first position it, we use these to position it. And then when it gets to that position, it draws the first line, and then it moves it again, and then we draw the second line. And now we're using I in range 3 because like we want it to repeat itself 4 times. We've already done one set and we need 3 more to get to 4. And so now we're saying I dot left 90. So like we're using this to position the turtle each time after drawing the line of squares repeatedly using the color that we want, because this one is alternating squares. We want it to alternate the colors. And after we have done all of this, we take it to the center of the screen and then we rotate it to the right. The 7th step includes drawing a diamond. As you saw from the previous images, the diamond is the shape that that was at the center of each square and grid. And so like this, we use this to draw just one diamond. So we're saying test the turtle's name, the size of the turtle, the color that we want for the outside, and the color that we want it to be filled with. And so it's a function which draws a diamond over the colored alternating grids. And so like in order to get it to draw the diamond, we have to position it, and we're using math.square root to, because like as you might have noticed, with the diamonds there were 2 it had like it was kind of like little triangles getting together, and so we had two hypotenuse, and so we're using this to calculate the equation using two hypotenuse, and so that's why we get the square root. And then after repositioning it, we put it INH 4, and this is what we use to draw the diamond, because the diamond has four sides. So we wanted to repeat itself forward, length, and then right 94 times. And the length is this square root, this weird number function like. And then we begin fill, so like we want it to be filled with a certain color. And after all that, we put the pen up and then we move it. And then we fill it again. And so this is used to give us more diamonds. So like, because that the first one, the diamond function was just giving us one function. But this more diamonds give us more diamonds. And so we have the parameters include total T, size, the outer color, and the color we want it to be filled in the inside, and the number of grids we want. And so this uses the helper function diamond, and it creates more diamonds. So like we're always positioning the turtle after each and every function, we reposition it so that it can work smoothly and repeat itself each time without giving us any problems. And so we put the pen up, we go to this position, and we put the pen down. And then um, we draw the diamonds twice. We get it to move this certain number of times, and then we draw the diamond. We move these number of times. It's like we have diamond twice. It's like this is repeating itself, and then after we're done, we put it back at the center of the screen, at the center of the grid and everything. And now the ninth step puts all the previous functions together and make them one function so that it's easy to call. So like we I called it one repeat pattern, and it uses all the previous parameters. Total T, size, number of squares, the color 1, color 2, and color 3. Puts all the functions together in one function, uses it to make a whole. So these are all the previous functions that we had. We had big square, square of squares, alternating squares, and more diamonds. And the final step we call the function. So we're calling the function using the previous function that we used. And that was one repeat pattern. The turtle is named Tess. We used the size of 360. We wanted 18 squares and the first color was light blue, the second color red, and the third color black. And this is the image that we get when we've done everything. So as you can see, we have the diamonds, and these are the alternating squares, and then this was the previous grid that we had. We said color 1, color 2, and it's being filled in with color 1. And look at the title that we have drawn. This is the border, and that's it. So thanks for joining me, guys. I hope you liked my video. Thank you so much for your time. Thank you very much. Have a good day. Have a good night.